Hi guys, welcome to Code Bashers. Guys, through this video, we are continuing our preparation series for TCS NQT 2024. This is the third coding video that we are posting, and past two coding videos are already present on this particular channel. I have made a dedicated playlist wherein you can find all the preparation related material for TCS NQT 2024. Currently, our coding series is going on, but slowly our aptitude series will also come. So make sure that you are present on this channel and are not missing any of the updates, because the test date is very near. It is on 15th Jan. So don't miss any of these updates that I'm posting on this channel, and be present on this channel. So do hit that subscribe button for the channel so that you can get the updates, and do hit the like button for us so that we can get motivated in making such videos, okay, without any breaks. So I hope you have done your part. You have hit the like button as well as the subscribe button. So now let's start this video, and again we will be discussing the coding question. So make sure to watch this video till the end so that you can get to know which type of questions are getting asked in the TCS NQT exam. So let's start. Okay, guys, at first this question might look easy to you, but believe me, it is not that easy. By reading the one line of question, you will say, okay, this is how it needs to be done. But believe me, you will end up doing this question wrong. We will be using the stack data structure for this particular question. So make sure that you're watching this video till the end. First, I will be discussing the question, then the stack based approach, and then finally I will be writing the code for it. So let's start by reading the question and getting the understanding of it. Okay, so we are given an array of integers. Find the nearest smaller number for every element such that the smaller element is on the left side. I know question might not, you have not understood the question. It is saying simple, given an array of integer, this is the array of integer that is given to us, this first one. Okay, find the nearest smaller number for every element. For every element we need to find the nearest smaller number such that the smaller element is on the left side. Okay, so let's just see. So this is our input array that is given to us, this one, 1 6 4 10 2 5. For every element we need to find the nearest smaller element on the left. Okay, so let's just see what it is trying to say. So currently we are at the first element. Okay, currently we are at the first element. What is the smaller element towards the left side of this element? Okay, what is the smaller element towards the left side of this element? So what is the smaller element towards the left of 1? So there is no element. So if there is no element, we have printed -1. That is, if the current element does not have the smaller element on the left side, we'll print -1. Now next, let's move ahead. So now our current element is 6. So what is the smaller element to the left of 6? What is the smaller element to the left of 6? So to the left of 6, the smaller element is 1, and the nearest smaller, okay, is 1. So we have printed 1 here. Okay, so we have printed 1 here. That is, 1 is the smaller element to the left of 6. Okay, next thing is 4. So what is the smaller element to the left of 4? Again, what is the smaller element to the left of 4? Again, it is 1, because 6 is greater than 4 and then it comes 1. So it is 1. Now we are at 10. Now you will make majority of you will make the mistake here. Now you will have to read the question again. Find the nearest smaller number for every element. So we are at 10. So what is the smallest element to the left of 10? What is the smaller element to the left of 10? And the nearest smaller element, that is nearest smaller element. So for 10, the nearest smaller element is 4. See, 4 is also smaller than 10, 6 is also smaller than 10, and 1 is also smaller than 10, because they are all on the left side. So 10 has 3 smaller numbers, but nearest smaller element. So nearest to 10 is the 4. So therefore the answer is 4. Okay, so the element should be on the left side of the current number. It should be smaller than that number, and it should be nearest smaller, because if there are 2 or 3 smaller numbers to the current number, there should be nearest smaller. Next is 2. Okay, so what is the nearest smaller number to the left of 2? So first we come to 10. So no, 10 is not smaller than 2, so it is rejected. Next is 4. Again, 4 is not smaller than 2, it is rejected. Next is 6. Again, 6 is not smaller than 2, again it's rejected. Next come 1. So yes, 1 is smaller than 2 and it is nearest also. So answer will be 1 here. Next is 5. So what is the nearest smaller element to the left of 5? So coming to 2. So is 2 less than 5? Yes, 2 is less than 5 and it is nearest also. So 2 is also less than 5 and 1 is also less than 5 and 4 is also less than 5. So what is nearest one? Nearest one is 2. So therefore 2 is the answer here. Okay. I hope this question, this sample input is clear to you. Next we will move towards the next input, that is 3, 2, 1. This is the elements. So when we are at 3, what is the nearest smaller element to the left of 3? There is no element that is smaller than 3. Okay, so therefore minus 1. Now we are at 2. What is the nearest smaller element to the left of 2? So in the left of 2, there is no smaller elements than 2. Therefore again minus 1. Now coming to 1, what is the nearest smaller element to the left of 1? There is no nearest smaller element to the left of 1. Therefore again minus 1. So in this case, a new array will be formed and all the elements in the array will be minus 1. One thing to note here is the first element of the array, okay, it will always contain the value minus 1, okay, because there will be no smaller element to the left of first element of the array. Okay, it is like common sense that first element does not have any smaller number to the left of it, so therefore always the answer will be minus 1. So I hope now the question is clear to you. Now let's just move towards the approach. I know most of you will be thinking, okay, we will keep on iterating towards the back side and whichever will be the nearest smaller will print it. But that is a time complexity approach, that will be n square. But I will be using a stack based approach that will be a less in time complexity, because in such exams time complexity also matters. So we will be using a stack based approach. Okay, so make sure that you're watching this video to the end. Okay, so guys, let's just now see the approach of this question, how we will be doing it. I have already told you we will be using stack based approach, but how to use stack based approach, let's just see now. So as I've told you that first element will never have the smaller element to the left because it's the first element. So in the output array, what we'll do, we will just do minus 1, and what we'll do, we will put this 1 inside the stack, because this 1 can be the next smaller element in the corresponding elements. Okay, so for the corresponding elements, this 1 can be the next smaller element, so therefore we have put 1 in the stack. Okay, now next element 6 comes. Now when this new element 6 comes, it will see whether there are elements in the stack or not. So if there is it will check the top of the stack. Okay, so top of the stack is 1, so it will check so whether the top of the stack is less than 6 or not. So in this case it is less than 6, so it means the nearest smaller element to the left of 6 is 1 only. So once this 6 comes, it will check the top of the stack. Okay, it will check the top of the stack. If it will find that the top of the stack is less than the current element, then it means that top of the stack is the next smaller element to the left. I hope this thing is clear to you. Now this 6 we will again put inside the stack, because this 6 can again is a good contender that it might be the next smaller element for rest of the elements. Okay, therefore we are putting 6 inside this stack. Now 4 comes. Okay, so once 4 comes, it will again, what it will do, it will check the top of the stack. Okay, as in the case of 6 we checked the top of the stack. Okay, so top of the stack in that case was less than the current element, that was 6. But now we will check. Okay, so 4 comes, so it will check the top of the stack. Now it will check, it will say that top of the stack is greater than 4. Okay, top of the stack is greater than 4, so this 6 cannot be the answer for it. Okay, as we have all agreed. So it will check that, okay, top of the stack is greater than me, so it means that 6 cannot be the answer. So it will remove 6, will be popped because it is not a valid contender for this 4. Okay, now it will check again. So 4 will again check the top of the stack now. Okay, so 1, yes, so it has found that now the top of the stack is less than me. So now this 1 is a good contender. So therefore this 1 is the nearest smaller element for 4. And again we will put 4 inside this stack, because this 4 can be next smaller element for rest of the remaining elements. Okay, now it comes 10. Now again 10 will come and it will again check the top of the stack. Okay, it will again check the top of the stack. So is top of the stack less than me? So 10 will say yes, because top of the stack is 4. Is it is less than me, so it is less than me, so it means that 4 is the answer. So 4 is the answer here. And again we will put 10 inside it. Why we are putting 10 inside it? Because this 10 can be the contender for rest of the elements. That 10 can be the nearest smaller element for the rest of the elements. We don't know till now that what are the rest elements. It is just visible on screen, but we have only traversed it till 10. Okay, now 2 comes. Okay, so 2 will again look at the top of the stack. So it will say no, 10 is greater than me, so it cannot be a valid contender. So it will remove it. Okay. So again, it will look at the top of the stack. It will say 4. 4 is again greater than 2, so it is not a valid contender. Okay. So it will remove. Now 2 will again check top of the stack. It is 1. So it will say yes, 1 is a valid contender. So I have found that top of the stack is less than me. So 1 will be the answer for this case. And again, we'll put 2 inside the stack. Okay, because 2 can be the possible contender for rest of the elements that we have not traversed till now. Now 5 will come. So 5, it will straight away look at the top of the stack. So it will find that it is 2. It is less than 5. So it means that it will say that yes, 2 is a valid contender and it is less than me also, and it is present on the top of the stack. So we will just do 2 here, and we will again push 5 here, because 5 can be for the rest of the elements. Now we have reached the end of the array. Now this is our output, and this is, I think, the required output only. So let's just see what was the required output. So -1, 1, 4, 1, 2. Yes. Okay. So I hope this thing is clear to you. The current element, when we are traversing, it will first check the top of the stack. If the top of the stack is less than the current element, then that is the nearest smaller element. Otherwise, if the top of the stack is greater than the current element, it will first pop the element. Then again check. If the top of the stack is less than me, again if it will be greater, again it will pop. It will pop till the top of the stack is less than the current element. Okay, so I hope this thing is clear to you. Now let's just see with the help of one more example. Okay, so let's just see this this example now. So first, as I told you, that this first element of the array, output array will be -1. Okay, now we will just place this 3 inside the stack in the starting only. Now we are at 2. Now 2 will go and check top of the stack. Now it knows that 3 is greater than 2. So it means it will pop the element. So this 3 will be removed from here. Okay. Now again 2 will check on the top of the stack. But see, now the stack is empty. So if we have found an element in which case this top of the stack is empty, that is the stack is empty, then it means that there is no further element there is on the left side of that element that is smaller than it. Okay, that is smaller than it. So in this case also it will be -1 here, and we'll put 2 in it. Once we will place -1 here, and then we'll put 2 in it. Now 1 will come. So 1 will again check the top of the stack. Okay, 2. So 2 is greater than 1. So what it will do? It will do pop operation. Now 1 will again now check after popping top of the stack. Now it will say that okay, now the stack is empty. So there is no top available. So it means that we have found an element, the current element. There is no smaller element to the left of the current element because the stack has become empty. Okay, so here also, in this case also, we will do -1, and this is our required output. Okay, so while popping all the elements, if the stack becomes empty, it means there are no elements on the left side of the current element that are smaller than that element. So I hope now the question approach is clear to you. Now let's just jump towards the editor for writing the code. And if you are finding this video useful and the previous 2 videos also useful, then do hit the like and subscribe button for this channel, because we feel very much motivated for making such videos. So now let's just quickly jump towards the editor. Okay, so guys, for saving time, I have already written the code and I will be like telling you line by line what each line is doing. So first of all, we have taken n as input, that what will be the length of the input array. Then we have defined 2 arrays. One is the input array and then another one is the output array, as we have discussed in the question. Next, this is the for loop for taking the input array, okay, for elements in the input array. Then we have declared the stack as we are using the stack based approach. And I have told you that in the output array, the first position will always be -1 because there is no smaller element on the left of first element is present. Therefore, on the output array, first index is -1. Next, we are pushing the first element of the input array into the stack, as I have told you that it will remain -1, but this 1 will be pushed into the stack. So therefore, this is what I have done in this particular line. Okay, then we are iterating over the rest of the input array. Okay, from index equal to 1 till less than n. Okay, what we are doing, first of all, when the current element comes to us, that is the current element, it will check the top of the stack, and once at top of the stack, if on the top of the stack will be greater than the current element, then it will pop, and it will continue to pop so until the top of the stack becomes less than the current element, or the stack becomes empty. So this is where this while loop comes. That is, we will be removing the elements from the top of the stack till they are greater than the current element. Okay, till they are greater than the current element, or the size becomes 0. Okay, so if these conditions are successful, till then we are popping the array. Okay, now once this while loop is over, either what is the breaking condition of this while loop? Either the stack becomes empty, or we have found the element on the top of the stack which is less than the current element. So that is why we are written this if else. So now if the stack becomes empty, after this while loop is over, then it means we have not found any element that is smaller than the current element towards the left, right? So therefore what we have done output array is equivalent to -1, because we have not found any element to the left of the current element which is smaller than the current element. Okay, this was the case when stack becomes empty. When stack is not empty, that is the else case, it means that now we have the element on the top of the stack which is less than the current element. So in that case, what we have done output of the array with the top of the stack, that what element at the top of the stack. Okay, so I hope this if else is clear to you. Okay, next, after for moving towards the next iteration, what we used to do, we used to push the current element inside the stack, because current element can be a probable contender, can be a good contender for next elements to come. It can this element can become the next one element for other elements to come. Okay, so this is how we have done, this is why we have done stack dot push the current element. Okay, so I hope this entire for loop and the logic is clear to you. Next, this for loop is written just because to print out the output array, that okay, which elements are smaller than the current element, that needs to be displayed. So that was information was present inside this output array. So now let's just run this particular code. Okay, and let's just see whether it gives us the correct output or not. So it is giving it -1 1 1 4 1 2. This is our required output. Okay, -1 1 1 4 1 2. And next was let's just test on the next input. It was 3 3 2 1. Okay, 3 2 1. So it gives -1 -1 and -1. So this particular code will pass all the test cases that will be given to you. Okay, I hope you liked the video and enjoyed it, and please hit that like and subscribe button for this channel, because it gives us immense motivation for making such videos. So guys, this was it for this video. Thank you for watching this video.